So recording
Look
y'all.
okay, so my hair's not standing up.
Yeah.
All right, so I'm gonna share my screen so we can start our 9.3. All right, y'all, so 9.3 is gonna deal with exponential functions. All right, so the first thing they want y'all to do is get familiar with what we call Euler's number. So that's Euler's number. Now, we're not going to go into the history of it. Some of y'all business people, y'all might get more into the history of it. But it's a number they came up with by doing growth from like interest rates and stuff. And it's like a horizontal asymptote that those graphs try to reach. So they will give you more information on that in your business classes. But I want to show you where the E is, because what they want us to get good at is finding E on the calculators and being able to approximate it. So there's two places to get an E. The first place, oh, let me look real good. It's over there by that divide sign, it looks like. So if I hit the second button and the division, you see how it brings that little E up there?
Oh.
And E is a constant, sort of like pi. Pi is what, 3.14? So let's see, E, when you hit enter on it, it's around 2.18. And remember, this is like pi, so that decimal keeps going on forever. So to punch it, you can hit the second button and the division button. There's also another place to get the E. So let's see, I can do it by second division. And then there's an E with an X on it on the left side. So if we hit the second button and then the LN button on the left side, that'll pull an E up with an exponent by it. So that one right there was what, second LN. So if you use that when you got to actually put exponents in on it, so if I put a 1 in it, E to the first should give me what, 2.1828. So the only thing we're going to do with this is take the E and approximate this thing to 4 decimal places. So we're going to use a calculator. To approximate the exponential expression to 4 decimal places. So 4 numbers after the decimal is what they're looking for on this. So the first one they want us to play with is E to the third. So I use the little crooked equal signs because those means you're approximating it and it's not exactly equal. Because when you got decimals, you're just approximating them and rounding off so many decimals. So on that one, I would probably use the second LN because it's got the E with the exponent. So I'm going to hit second LN, pull up the E, and then my exponent was a 3, so I'm going to put in my 3 and then enter. So this one is what, 20 point, so I got to go 4 decimal places, so 0855. So the 5, I can keep a 5 because the number after is a 3. Had that been a 5 or greater, I would have had to round that up. So this will be 20.0855. Okay, so that's all they wanted us to do on that is just approximate that and see what we get. Now, how about E to the negative 3.46? So same thing, y'all. I'm going to hit the second LN, get my E up there, and then I got what, a negative 3.46. All right, so we push that in, hit enter. Now, since that's a negative exponent, it's got to be less than 1 technically. And if you notice, that is what, 0.0314.
1, 4.
And then, yeah, I'm going to go with that because that 4 had a 2 after it. Okay. All righty, so they wanted us to
So
get
did
good
we
on.
round did we round these decimal places?
Yeah, it's rounding it to 4 decimal places. Now, let me show you
So
a
like
trick.
that one had a 2 after it. If it had like a 5 or a 6, would we round that up to a 5?
I'd have rounded it up for sure.
Okay.
Okay. Now, on problems like that, if you do have issues rounding stuff, you can hit that mode button on your calculator. And if you hit the mode button, go down to where it says float and go over to 4. So when I hit a 4 on that, that means now I'm going to round my stuff off to 4 decimal places. So now watch this when I put my E to the negative 3.46. When I put it in like that, the calculator will automatically just round it 4 units. Okay, so that's what that mode stuff is up here where it says float. Float will carry the decimal out as far as it needs, and then everything else, 0 decimal places, 1, 2, 3, and so on. So I'm going to set mine back on float now and then clear that screen. But yeah, you can set them modes on 4 and it will actually round it for you.
Cool.
All right, so next we're going to look at graphing. So graphing exponential functions. So I'm just going to draw a basic one here and go out about 5. So I'm going to show you how I would graph f of x equals something like 2 to the x. The variable is now going to be the exponents. And these got sort of properties. They're always continuous, which means there won't be any undefined sections on them. And numbers I always pick, I always use a 0 for my x. So here's a question for y'all. Any number that has an exponent of 0, what will that give you as an answer?
0.
Oh, pick again.
Mm-hmm.
Just
1.
number.
1.
Oh, who just said that?
Both me and Danielle.
Someone said a 1.
Yeah.
That's it. Anything to the 0 power equals 1. Which means, since these are all exponents up here, anytime there's a 0 in it, that thing will cross right over the y-axis at 1. Another number I always pick would be that number, would be a 1. Because anything to the first power is basically itself. So if I put a 1 in for the x, 2 to the first would be a 2. So at 1, this goes up here to 2. All right, next I would probably pick, what, a 2 on that. I'm trying to keep my exponents a little small on this. All right, then 2 squared would be 2 times 2 would be 4. So over here at 2 is going up to 4. And y'all start saying this, the bigger these exponents get, the more steep this is going to go up. Almost sort of like that exponential corona curve, right?
Funny.
And then on the
that
left
last
side,
night
what it
about-
would do,
That made me had a heart attack.
on the left side where this is negative x's, it's going to come down and try to get on that x-axis, but it never can. So it does like a horizontal asymptote that way. And then to the right, it's just going to keep on increasing. But things you want to know about them, every one of these graphs, if we don't have any translations going on, will go right through 1 on that y-axis, okay? Now, these ain't bad to graph. I can go in here, go to my y equals, clear that. And I did what, 2 to the x? So I would do 2, and then my exponent, x. And then I'm not sure what my window's at, but I'm just going to hit enter and see.
Hold on. So we do 2, and then we do the e? No. Just a regular exponent?
Yeah. So since you're just putting in an x for an exponent, all I did was I went y equals. So I did my 2, and I use this little caret over here under the clear button for my
Can't
exponent.
really see. Oh, wait. Hold on. There we go. Never mind.
And then I just hit my x. So that in there, I got what, 2 to the x. Let me move it over here. Mike can see it better.
No, I was zoomed in again.
Oh, okay. Yeah, we did that yesterday, I think, when we set them up. And then when I hit graph, let's see. So you can see how it goes right up through there like we drew, right? Going right through the 1 there, and then it's increasing. And then you can look at the table they got. And there's our numbers, 0, 1. Then we had what, 1, 2, 2, 4.
So which exponent did you put in for that first one?
Do it now?
Which exponent did you use for this first one?
On my graph?
Yes, sir.
I use 0 first.
Oh, okay. Okay, yeah, mine. Actually, no, mine didn't work.
Say again?
Mine didn't work.
What do you mean?
My graph didn't go.
Hit zoom on top row. There's a zoom button and number 6 for standard.
I don't know. That's okay. I don't know.
Is it saying anything though?
No, I was supposed to put 2, and then I was supposed to put the 0 in the exponent.
Oh no, you just
I
trying to.
put the e first, right?
Well, okay,
No,
I was doing that by. Okay, I was doing that by hand. If you're doing it on a calculator, are you trying to punch it on a calculator, Raquel?
Yes.
Okay. So go to y equals.
Yes.
Anything is in it is cleared. So
Yeah.
I'm doing this graph of 2 to the x. So hit your 2.
Right.
Exponent up. And put that x.
Mm-hmm.
And then hit graph.
Oh, an X. Okay.
Yeah, use the x, because if you use a 0, it's just going to make a straight line going right across.
Yeah.
Okay.
Okay, I got it now.
Okay.
You got baby brain kicking in?
Well, yeah, and it's early.
Oh my gosh, this is why she didn't tell anybody she was pregnant.
Oh.
Just for the record, Raquel, I'm still mad at you for that. I love you,
I'm
but I'm
not.
still mad at you.
I told
You
my
should have
mom
told
yesterday,
me.
so.
All right, y'all. So y equals 6 to the x. I still know that if I put a 0 in for the x, 6 to the 0 would be 1. And then let's see, if we put a 1 in there, 6 to the first power would be 6. And then how about a 2? 6 to the second power. Ooh, look how fast this one grows. So just the exponent of 2 put that up to 36 already. So let's go here and graph that one. So that would be 6, and then my exponent would be the x again. And then I'm going to hit enter for graph. Now notice, it's got the same shape, but it is a lot steeper because that one's growing at a quicker rate. So what I wanted y'all to see was if I started with 2 people being sick, it would grow like that first graph. But if I started with 6 people being sick, look how quick I got to 36 people. By just them spreading it twice, right? So that sort of shows you how quick things can grow exponentially. Now, did y'all notice though, they all have the same shape, right?
Mm-hmm.
Mm-hmm.
But when you graph them on MATLAB later, you're going to pick is the shape that looks like it's going uphill to the right. All right, so let me show you what will happen on this one. This one we're going to have y equals 1/3 to the x. So if you put a 0 in for that x still, it will still go through 1. And then this time if I put a 1 in, 1/3 to the first is still going to be a 1/3.
Mm-hmm.
If you put a 2 into that, square the top, you get a 1. Square the bottom, 3 times 3 is 9. So notice this one is actually getting smaller to the right.
Mm-hmm.
Now, had that been a negative exponent I was using, a negative exponent, you would have to flip the fraction so that you get 3 to the first, and 3 to the first would just be a 3. So notice, this one's getting smaller toward the right, but it gets bigger towards the left. So this one, if you was going to have it drawn,
It'll look the opposite of the first two we did.
exactly, because see, it's still going to cross at 1, but this time it's getting smaller to the right, and then on the left side, it would try to go towards positive infinity. So the trick on this one, y'all, when you graph it, put the fraction in parentheses, unless you use that alpha y. So I would do parentheses, what I have, 1 divided by 3, close parentheses, and then I would put in my exponent of x.
Mine did it, and I didn't use the parentheses.
Well, some of them will because it's dividing before it's doing the exponents, hopefully. But let me see, did your graph go downhill like that?
See, that's
Mhm.
that's how
Oh, yeah.
I put mine in,
Uh-huh, that'll work.
and then
Hit
graph.
And there you go. Okay.
I know Miss McConnell said that some of them may work that way, but if you're working with fractions, always put them in
Mm-hmm.
the parentheses.
Yeah, and the
So-
reason that one did good was because it knew to do the fraction first and then the exponent. But sometimes they'll have trouble figuring out what you want them to do. All right, now this one you see a fraction like that one had, but notice the difference. The fraction don't have the exponent, the e has the exponent. So since the e has that exponent, we're expecting this one to still sort of go uphill left to right. So
Bless
that
you.
one, I would probably definitely put my fraction in parentheses because you got a lot of things going on. And then e to the x, I'm just going to hit second ln, bring up my e, and then put in my x for its exponent. All right, y'all, then we just hit graph. So notice it still does the uphill. The only difference is if we go to the table, where this is 0 is not actually going through 1 this time because of that fraction out front. It's going through 3/4, which it's writing as a 0.75 because it did 1 times the 3/4 to get that point. So most of those, y'all, you can just plot them on that calculator and graph them. But what's coming up is a little trickier, okay? So we're going to look at our translations. So these are just a little bit different than the parabolas we did earlier and stuff. So y equals a to the x. At the end is a plus b. When you added a number at the end of those functions, if it was positive, it moved up. If that was negative, it moves down. That's still true on the exponentials. Here's where we're going to have just a little bit of difference. Now, I'm going to attack the exponent.
Oh man, I've seen those before. I didn't like the thought of those.
Now,
I've
if you
seen
attack
those
the
every
exponent,
time I do anything.
it's going to do the same as the stuff that was in the parentheses. So when we attack the x in the parentheses, or when we attack the x at all, if you're adding a to it, it's going to move me left. If you subtract a, it's going to move me to the right. So these are basically still the same moves. Add at the end is up or down. Attacking that x is left or right. Y equals negative a to the x. When you threw a negative in front of that function, it reflected across x-axis. So here was the new move I was telling y'all about a few weeks ago. I'm going to have a to the negative x. Now I'm making the x negative. If I do that, that will reflect across the y-axis. Okay, so left, right, up or down, left or right, reflect the x and reflect the y. So they're going to give us on this first one, f of x equals 2 to the x minus 1. So on this one, we would start
It's going to move
with,
down.
so you're going to start with the
It's gonna
graph
move to the right, right?
of 2 to the x.
Yeah.
Now, I've heard two different things, but that minus 1 is up there with the x in the exponent. So remember
Yeah,
when
I'm seeing that now, so it's going to move it to the right.
so we will move to the right. So we move right. What's that? 1 unit?
Mm-hmm.
And then that's it. And then we just hit, you'll put that answer in, and then you'll, on MATLAB, you're going to go on MATLAB, click your graph. You got to choose the tool that goes uphill. Once you choose that tool and click on the graph, it's going to bring up those slide controls. So remember the ones that had the vertical and the horizontal, and you had to move it left or right on those to move it up or down. Also, it's going to have little boxes that says reflect X and reflect Y. You gotta click one of those if you're reflecting. But y'all, the most important thing when you're graphing, down here on the bottom left, it says base. You gotta put your base. So on my problem, the base is the 2. So you would have to come down here and physically put a 2 in there. By default, it's got the E in that, okay? Now.
Okay, so this one we're not reflecting, so we wouldn't check either box, right?
Right. So on that one, all I would do was, since I was going left 2, I would move my horizontal left.
We're going right
1, right?
Yeah,
So
not
we just
left
went
2,
left.
right 1.
Left 1, okay?
Okay, Mr. Rathwan, how do we put in the graph? We just do it the same, like x minus 1 when it gets to the exponent?
Oh, if you're doing it by calculator?
Yeah.
So on that one, let me clear that. So on that one, I would do my 2 exponent and then x minus 1. Now, if you got an older calculator, so let me show you. When you got a older calculator, you would put the 2 when you hit that arrow up, it'll bring you parentheses. So on those old ones, they would have to put x minus 1 in parentheses and close them. But most of y'all that had the new ones, it kicks it up there like mine does, so that you can write the whole exponent and then be done with it, okay?
Okay,
Let's
let me
see.
ask you a question.
Uh-huh.
So that where you wrote like the horizontal, you said it went to the left,
Left one.
but it
Oh,
doesn't that go to
yeah.
I'm so confused. I'm like, is that just a
No,
math
no, you're
lab
right. It's
thing?
right one. Hell, I actually wrote it right here, right? 1 unit, right?
Yeah. I was very confused. I was like, what is going on right
Well, at
now?
one point he was talking about moving it left too.
Yeah, I think I started getting mixed up on it. I was saying move it left or right, and then somehow I got ended up on the left. But we wrote it right there. You got to move it right 1 unit. And if you
Okay.
notice my calculator, this part right here was at the 1 when you started. So by moving it right 1, it kicked it over.
You're slipping, Mr. Rathlin.
I'm doing what?
You're slipping.
Oh. All right, figure out this move on this one. This is f of x equals 4 to the x plus 5. So we're going to start with the graph of 4 to the x. What's that move doing to me?
Is that a small 5 or a big 5?
It's a 5. What you mean a small 5 or a big 5?
Like, is it up there with the exponent or is it with the 4?
It's at the back.
Oh, okay.
That one's going to move up 5 spaces.
So it's going to move up 5 units. Now, I'm sending a video. I can't remember if I've sent it already or not, but I'm sending a video for 9.3 graphing. And I show you actually how
It was for today. I think you did.
I think I saw it already there in the email.
because it shows you how to do these graphs on MATLAB, okay?
Mhm.
So the main thing on this one, you got to remember, change the base to a 4. And then you would click the vertical up 5 and be done on it, okay? All right, let's see what y'all do with this next move. Oh yeah, here's my tricky one. F of x equals 3 to the 1 minus x plus 2. So I'm going to start with graph of 3 to the x. I will tell y'all I
So
got
it's
3
going
moves.
down and it's reflected across. It's going down and it's reflected across the y-axis.
Okay,
No, because it's not a negative base.
Oh, going up. It's going up
okay, so the plus 2 is going to move me up 2 units.
and it's reflected.
So it moves up 2 units. The negative x means it's reflected across the y-axis.
That one is just there to be like a
Oh, no,
placeholder or what?
No, that 1 tells me something also. That 1's up there with that.
That one's going to tell you that it's moving right. No, it's going to move left because the one's a positive.
Yeah, so it's gonna move it left 1 unit.
1 unit. There you go. So you could put that in order if you wanted it to be like a negative x plus 1.
Right.
But yeah, the 1 moved me left, the negative x reflected me, and then that 2 moved me up 1 unit. I mean 2 units. And then you'd have to put all these moves on that MATLAB. So I did a problem like this on that video I sent y'all. You got to click the little box, reflect across the Y. You got to do the vertical to get that 2, and then you got to do the horizontal to get the 1. And then in the base, you better put that 3, or it will mark those wrong, okay? All right, so y'all got pretty good on that. And let's see this one. 2 minus 2 to the negative x. So I'm going to start with the graph of 2 to the x.
Yep.
Now, we'll say that this 2 in the front is out of place. It would look better if it was probably sitting at the back.
Mhm.
So that 2 is going to move me.
Up 2 units.
There you go. Up 2 units, definitely. How about this negative in front of the 2 right here?
That's going to reflect us
Oh, no,
across.
reflects across the x-axis.
Mhm.
We are rolling today. Well, how about that little negative in front of that X?
That's
And
gonna go
it's gonna
across the
reflect
y-axis.
y-axis.
Right? Reflect across the Y. So we said this one reflected across the X and the Y. So watch what happens on this one. I'll just graph it real quick so you can see. So 2 minus 2 exponent negative X. So that when you graph it, it should be on the downside and flipped.
Oh, wow.
Pretty cool because remember, it should be coming downhill to the right. And now it's going uphill
Mr. Rathbone, can you click on your Y button again? Just real
on
quick?
my Y button. Mhm.
Yeah, your Y equals.
Yep, so I just got my 2 minus 2, and then that was a negative X.
Mhm. Okay. Thanks.
All right, so let me do one more of these, and then I'll play with y'all business people stuff.
Mhm.
So f of x equals 2 to the x plus 5 minus 3. So we will start with the graph of 2 to the x. So I guess, what's the negative 3 doing?
Moving this
Going down 3.
units.
Move down 3 units. And then how about that plus 5?
Going left 5.
It moves,
Is that
yeah,
left?
to the left.
Definitely moves left 5 units. So this one I would use my base 2 again, horizontal left 5, and then vertical down 3 and be done. All right, so we're going to play with a formula that figures out the amount of your payments when you're given a principal balance, and then this is 1 plus R over N, all to the N T. So this is sort of the formula they use to get the E from, but I'm not going to get into all that. So A is your amount.
That you start with, right?
No, that's the amount that you have in your account at T years or T months or whatever your time deposit is or whatever.
Mhm.
P, so A is the amount. P is your principal balance or your starting amount. So we'll call that the starting amount.
So that means P is actually what you started with, and A is what's actually in there.
Mm-hmm. Exactly. So how about R? R is
Rate?
your interest rate.
Mhm.
Now remember, when I use it in the formula, my interest rate has to be in decimal form, okay? N is
So
the
that means if it
number.
was like 3%, if it was like 3%, it would be like 0.03.
Exactly.
Okay.
Mm-hmm.
Keep an eye.
N is the
You said
number.
it has to be in decimal form?
Oh yeah, you can't multiply by percent, remember. You got to turn
So
it
if
into.
it's
That's going to be the number of
Three-
payments.
Say again.
Is that gonna be the number of payments?
N is the number of compounds.
Compounds?
So if it was 3.5% interest rate, then it would be 0.035, right?
Yeah.
Okay.
You're just moving that decimal left 2 units and being done. So number of compounds, it could be like compounded annually, semi-annually, quarterly. So that would be
Oh,
the
would you
stuff we're
put like
talking
a
there.
1 for 1 year or what?
Do what now? So
If it was annually or semi-annually,
annually
it'll
would
be
be
a
a
1?
1. Semi-annually would make that a
so
2.
half, would be like half? Oh,
Semi-annually.
okay. 1 out of 2.
Quarterly would be a 4 here. Okay.
Oh, okay. And it's gonna be a fraction. Yeah.
Right. Well, you'll see when I hit them.
Okay.
And then T is time in years. So what they're saying on this one, suppose 59,000 is invested at 6.5% interest, compounded quarterly. So they got an A. We're going to find the function that models the data after T years. So we don't know how many years, but they want me to figure out everything else. So my function would be A equals, and all we're going to really do is start filling in for stuff. I know my principal balance, which is my starting amount. They gave me that
So that'll be
was
59,000.
59,000.
59,000.
Then you got your parentheses,
And
and
then
it's
a
always 1 plus.
Mhm.
Well, what's my R?
Rate
So it's 6.5%,
is
which is like
B.
6.5.
0.065.
So 0.065, perfect.
65. And then over 4?
So where was quarterly would be
You
over
said quarterly, right? A 4?
job. And then you got N times T up here. So N once again is going to be 4, and then my T. So
Yeah.
we basically got what they want. The only thing is they work this part out inside the parentheses. So I'm going to bring down my 59,000. I guess because they figure you can do more work to it. So what they usually want you to do is simplify this part in here. So let's see, that's what, 1. Let me clear everything. 1 plus 0.065 divided by 4. That's going to give me 1.01625 inside the parentheses, and then I'll still have my 4T on the outside.
Was that all of? Yeah, that was all the decimal places. Okay.
Yeah, usually on this, you're going to write everything out, but it shouldn't get too big.
Okay.
Okay, so that was part A. So we got that formula now.
I don't know if I just like this because I'm slightly interested in finance. I'm not really sure how interested I am, or if it's because it's money. But
Well, here you go.
I hate this for the same reason.
yeah, I might still go into finance. I think I like this.
So now find the amount to which the investment grows. Or you could say the virus grows.
Oh
Which the
no,
investment
let's keep it
grows.
money.
Money.
After T equals 0, 3, 6, and 10 years. So basically, I got to take the formula we just came up with and put in these 4 numbers and get 4 different answers. So I'll
Now
do,
we know T.
so
Options.
let me see what they wanted. T equals 0, 3, T was what, 6, and then T was 10. So basically, that formula we just came up with, I had what?
So is this compound interest?
It's compounded, yeah.
Uh-huh.
Now, the one y'all are more familiar with that we will see in about another week or so is what we call continuous interest. And those are the ones
Mhm.
that you probably get set up for when you do a house loan or something, you know?
Yeah, because they're more stable.
Yeah, and it's just continuous and it really fluctuates according to the, the prime interest rates and all that weird
Mhm.
stuff. Y'all learn all that, so.
Mhm.
All right, so first, now, do you want to sit and punch these 4 different numbers in all day, or do you want to do it the quick way? The quick way would be my
I
graph.
won't do it the
Let's
quick
be
way.
quick.
So watch this. On the graphing and y equals, we're going to put that equation we just got, 59,000. And then I had parentheses, 1.01625, close parentheses. And then the exponent was be a 4. Now I'm not using a t on this. I'm going to use the x for my variable, okay?
Oh, okay.
So I got everything in like it looks. Just remember, because the calculator is doing your y's in terms of the x's. Now, you can graph it if you want to. It should go uphill like we've been doing.
Hang
But
on, so
y'all-
how did you put that in there?
Okay, so let me clear. So I did my
The
59,000.
4, the
So I did my 59,000. And then I just put in the decimal I got, 1.01625. Close my parentheses, and then I arrowed up to
What
do
about the
the.
number 1? What about the +1?
Oh, remember, I'm using the final formula I came up with for that problem.
Oh, because, oh, okay.
Yeah,
it's
we
the-
done figured out that 1 plus 0.065 over 4.
So the 1 is what makes it, 1.0.
Exactly.
Okay. That 1
Uh-huh.
is already there. Okay.
Right. So let me put in the 4x. Now, I'm not graphing it. I'm going to hit second table.
How are
Second,
you putting in that 4x?
I did the
It's a
exponent.
4 and an x. Exponents.
So let me delete.
And then
So I'm at this
4x.
right here, Kelsey. I hit that arrow up over here. And then I put
Right.
in, and then I put in
just
4x.
And then,
Mhm. Now, I don't care about the
okay, that's
graph.
what I want.
Right. Y'all going to hit second graph to pull up that table. So what was the
Okay.
first number I was looking for? 0?
Oh, wow.
At t equals 0,
Yes.
you better have 59,000 in there, right?
5,900.
So what y'all got at 0?
Oh, yeah. Mhm.
What do y'all get at 0?
0.
Mhm.
What's the y
59,000.
value? What's the y value?
59,000.
59,000.
0. The y value is
1? Oh, 1?
So at t equals
No,
0,
it's 59,000.
you should have 59,000 because remember, ain't no time passed, so you better have all your money, right?
Right.
At t equals
otherwise,
3,
that's a bad investment.
at t equals 3, this better start going up. So let me arrow down to 3. And at 3, looks like I've got 71,000
71,591.
and 591. How about 6? We go 4, 5, 6. At 6, I've got, oh, y'all read Jaws. It's hard for me to read. Looks like 8.
I got
86,
something different from what y'all got.
869. 86, 869.
Uh-huh. And then finally at 10,
And then for 10, it's 112, 428.
428. So Kelsey, what's it saying on yours?
Hang on. So for mine, for 0, it's got 0, and then for 3, it's got 188,788.
Hang on.
That's what mine has too.
All right, so let me see.
Huh.
Y'all got these in wrong. So let's go back to y equals. So I'm gonna clear this out. So at y equals, 59,000 goes first. Okay. Open your parentheses. Inside the parentheses, we're going to put
Okay.
1.01625. 0.01625. Close those parentheses. Now we're going to arrow up to do our exponent. So arrow up, and then
Yeah.
we're going to do 4x. Now, when you hit the exponent, does yours put parentheses or do it like mine?
Mine just, it's not doing parentheses, but it's not doing like yours either. It's got the little arrow thing and then just 4x.
Okay, so here's what you do.
It's not like
Check this
yours.
out. Watch what I'm about to write here, okay? On yours will have 59,000, parentheses, 1.01625, close parentheses. You're going to arrow up. It's going to give you that parentheses. You're going to put 4x and close those parentheses.
Okay.
So if y'all's does the arrow up and puts the parentheses, you got to put 4x and then close them. So try that and then see if your table starts giving you what you need.
Yeah, there it goes. So I just need to put my 4x in those
So
parentheses.
anytime you got exponents and it's more than one thing, close in parentheses off, okay? Because what yours is doing, it's raising this to the 4th power, and then it's taking all that and multiplying by the x's. Because it don't know that it's
Yeah.
in with the exponents with it, okay? All right, y'all, that was that one. So let's see. My last question for this section is on Melissa's 6th birthday. She gets a $6,000 CD that earns 6% interest. Compounded quarterly. If the CD matures on her 14th birthday, how much money is available?
So this one, we're gonna have to start with 6. Like, we're gonna have to figure out that it's not it's gonna be like 6 plus the years or what?
So I'm going to fill in that formula so we know we got our A, right? So what would be my P for this problem? My principal balance.
The 6,000?
6,000.
The 6,000?
Mm-hmm. And then remember, it's 1 plus, well, what's my R?
0.06%?
Right, because you got
0.06.
6%, you got to turn that into what, a 0.06? So good job. My number of compounds.
Is it gonna be 4?
4. So that means out here I'll have a 4. Oh,
And
what is T?
14th birthday. So it'll be 14 minus 6.
14 minus 6. And that'll give me 8. So that 4 is actually going to get multiplied by the 8 this time. So now, this is how you would tell after what, 8 years on her, how much money is going to be in her account. Now, they could have done this at 2 years, 3 years, you know, to sort of keep up with it. All right, so let's clear that out. And this is nice because I'm just going to punch it all in like it looks. So 6,000, parentheses, 1 plus 0.06 divided by 4, close parentheses, and then this time, well, 4 times 8, I know that's what? 32. Or you could put 4 times 8 there and it'll still do it. Now, they want me to round my answer to the nearest cents. So let's see what we get. So I know that's going to be 9,660. Looks like the 1. So what y'all going with on cents?
I haven't got there.
So I'm showing a
So-
9661.945921.
You got that 4 in the equation because it's quarterly, right?
Yeah.
Right,
Okay.
right. So you're only going to have 3 choices on that, Mandy. It'll be annually, which will be a 1. Semi-annually would be a 2. Quarterly would be the 4. All right, so what am I going to make that, a 94 or 95?
95 because it's gonna round up.
There you go.
Yeah, I think I like this.
And that'd be your final answer on that, okay?
I don't think anybody would like this as much if you really started using a virus. I think this is more relatable.
Mm-hmm.
It's funner. Hmm. It's not as interesting if it's a virus, I guess.
Mm-hmm.
I feel the exact opposite.
Oh, really? You don't like money?
Yes. I'm not good with money.
Okay, I'm into investing.
It's a rough subject for me, okay?
I'm learning
no.
a foreign currency exchange and money. So
All
No.
right, so 9-4, I probably won't get much into it. I just wanted to do some of these definitions. So these are logarithmic functions. So let me draw sort of what a log looks like. So a logarithm has a base, and then it has the result, and that's going to equal A. So the B is what we call the base of the logarithm.
so that B
Hey.
is little. That Y, is that Y in line with the log?
No, the B is like a subscript, and then the Y
Right.
is in line with it.
Okay.
All right, A would actually be the exponent. And Y is the result of B raised to that A. So if this B was a 2 and A was a 3, this would be 2 to the 3rd power, which would make that Y a 8. So basically, let me show you what's going on with these. How about if I have a 25 here and a 5 here? What this logarithm wants me to find is what exponent. Oh, Hank, let me rewrite this a second. Log 5 of 25. How about that? That one we can do. I'll do this and later when we do square root stuff. But what this logarithm wants me to find is the exponent that I can raise 5 to make that a 25. So think about this. 5 to
So
some
we know it's 5, but yeah, how?
So see, you got 5 to
So
some
the
exponent.
exponent would be 2
would be a
because
2.
5 times 2.
Oh yeah, that's
Well,
right.
5 times 5 is
5
25.
times 5
The
is
square.
25, so the exponent would be a
But
2
it
on
gets
that.
more complicated when it's not round.
Well, I'm just going to play with these a second and see what y'all do with them. What if that was
So the 25 is the Y?
the 25 is the Y.
Mm-hmm.
Okay.
So that'll
So
be
look at this
9.
one. So this one says, hey, you start with a 3.
Mm-mm.
What exponent would you raise that 3 to turn it into a 27? Well, 3
9?
times,
Would it be
well,
a 3?
3 times 3 is 9. 9 times 3 is 27. So that would be a
3.
3. Now, you know the calculator takes
Okay.
care of y'all for that. I'm not sure about the older ones, so we need to
Right.
see. So y'all push this button and see if y'all got what I'm about to find. Push the math button and arrow down and see if you got something called a log base.
Yep.
Hold on.
What am I looking for?
Log base.
I'm trying to get my
I do not have
calculator
it.
out of this. Y equals.
Okay.
So I do math. Then what?
So
Oh,
to
log
look
base.
for it,
Okay.
so hit math and just arrow down and see if you got a log base.
Okay.
Older calculators might not have this. If I was in school, I could.
Mine doesn't.
Okay, so I'd show you another way in the future. But if you get on that log base and hit enter, look what it pulls up.
Yes, that's what
So
I'm
you could
talking
put your
about.
3 here.
Mhm.
You could put your 27 here. So now it looks exactly like my problem. When I hit enter, I get my 3.
We say 3, oops, 27.
Mhm. So here's the general form of these. Log,
Look at that.
did y'all get it?
Ain't God good?
All right, so
Yeah,
watch
mine
this.
had nothing in this base. It didn't teach me.
Yeah,
the
I'm
other
gonna
way.
show. There's no way for me to upgrade your calculator since we're not in school, so I'll show you another way that we can do those on yours. But y'all, log base b of y equals a if and only if b to the a equals y.
Mhm.
So logarithms and exponentials sort of undo each other, okay?
I hear somebody's kid in the background.
My bad.
It ain't more than it.
All right, so I'm probably going to stop around in here. I just
I'm
wanted
sorry.
y'all
I thought I had that muted.
I just wanted y'all to get some of these definitions on those so that when we start these on Monday, they're not way out there on you, okay? So just basically, a
Mhm.
logarithm is a exponent, okay?
Mhm.
So now on my ancient
So let me
calculators,
show you on yours. So
yeah.
we had an actual button we could do on ours. Kelsey, what you got to do on yours, if you was going to do this problem, log 3 of 27,
Mhm.
you would do the log of the 27 divided by the log of the 3. And then close in parentheses. So do that and you should get what I've got. So let's see. Log 27, close parentheses, divided by log of 3, close parentheses. And when you do that, you still get a. You getting a 3 on that, Kelsey?
Well, no, but that's because I put in 37 and not 27. Let me try it with the correct numbers in it.
Okay.
7 divided by log 3. Close that off. And then, yeah, I got there. Okay, so that's the way I have to just.
Right.
Okay.
And always remember, it's the top number always divided by that log of that bottom one, okay?
Okay.
So actually, they call that the change of base method.
So, okay, yeah. So basically, I'm going log of the exponent divided by log of the base.
Yeah, or the result divided by the base.
27 is our exponent, 3 is our base on that.
Right. So to see if you're getting good on that, Kelsey, do this one. Find me the log base 3 of 81. So y'all see what y'all get. Log base 3 of 81.
I got 4.
Bam, that's it. Right, 3 times 3 is 9, times 3 is 27, times 3 is 81.
That's why I doesn't have to sit here and go through bad steps to do it on my calculator. But really, this ain't bad at all.
Oh, these
Might have
ain't
known
gonna
what
be too bad.
numbers.
All this will start getting us ready for those exponential and logarithmic equations next week. So we'll pick up 9.4 Monday.
All right.
That was
Maybe.
a good full class.
Say again?
That was a good full, like, we learned a lot. It was good.
Yeah. And we've only got a few sections mainly we got to get through. 10.2 I took off. 9.5 will be the tricky one. 9.6 a little tricky, but I think we'll make it through this. Yeah, well, when y'all move on, y'all got all the material you need for, I guess, stats, right?
Well, the good news is we'll have you to work with us, so.
We're trying.
I just want you to understand, like,
Yeah,
I hate this. This is not okay.
What is that?
Don't like what?
The money thing.
Oh,
Oh, really? Girl,
You
it's
know,
okay.
like
We'll,
it.
we'll work.
I'm not
We'll
happy
work
about it.
We'll work together, girl. It's as simple as just.
so here you
understanding
go.
What each of those numbers.
If you take your $1,200 stimulus check
There we go.
and find somewhere to invest it at maybe 5% or something, you know, we can figure out how much time it would take you to have $1,500 or more, you know.
Please don't do that. It's just gonna make me depressed
It will.
because it's all going to bills.
Or
Like,
we could do like a mortgage rate or something. You just
Uh-huh.
have to
Hey,
understand
Mr.
the variables.
Oh,
Rathbun.
those will coming up in probably 9.6, I think is where we see the continuous compounds.
Yeah, that's right.
So,
Mr. Rathbun,
Just don't tell
You said
yourself you
that
don't
the,
like it, and you'll be doing a little bit better.
I've liked the entire rest of this class, and now I'm like,
You'll like
My
this
life.
too. You
But-
just you have to
but-
frame it in your mind that it's actually simple. It's a formula.
but there's only two of them you got to worry about.
okay.
Mr. Rathbun,
Now, here's the
you
formula you
said
got coming.
did you say that the bonus sheet is due Friday?
Due by Friday night.
Okay.
And then once I get them all Friday night, I'll go through and change all them test stuff I got to.
Hold
But y'all,
on. What
here's
are you
the-
doing, Mr. Rathbun? What is
This
that?
one right
I
here.
haven't taken my test yet. I'm
Uh-huh.
gonna do that today.
So don't worry about this yet, but this is the one we
that bad,
use
girl.
for continuous interest would be this one. PO would be the starting amount. There's the E that we learned about. K is the interest rates and T would be the time. So for
Okay.
continuous, they use that little E for you. So
Mandy, it's just a formula. So don't
Yeah.
tell yourself it's
And then-
overwhelming and you'll be doing
and
better.
then
I just
Hey.
don't like money.
y'all ain't got to worry about them.
Well, let's talk about a virus. Yeah, yeah, Mandy, as long as you understand the annual, the biannual, and the quarterly, and we know what those fractions are. Biannual is 2, quarterly is 1 out of 4.
So I thought there were 4 different ones that you could have, but it's just
All right,
annual,
I'm gonna stop the
semi-annual.
recording. So let me go back to my,
Yeah, I think it's just those 3, right?
say again.
Annual, semi